Did you know what are positrons? Let's explore. Positron is the antiparticle of the electron. Simple definition. A positron is a subatomic particle that has the same mass as an electron, the same magnitude of charge, but positive instead of negative. So, it is often called a positive electron. Important points. Symbol, E positive. Charge, +1 positive. Mass, equal to electron, 9.11 into 10 raised to the power -31 kilograms. Spin, same as electron. How are positrons formed? Positrons are produced in radioactive decay, especially beta plus decay, high-energy processes like cosmic rays, particle accelerators. What happens when positron meets electron? When a positron meets an electron, they annihilate each other. Their mass is converted into energy, gamma rays. This is called annihilation reaction. Uses of positrons. Medical imaging, e.g., PET scans, positron emission tomography. Scientific research in particle physics. What are quarks? Do you know? Let's explore. Quarks are tiny fundamental particles that combine to form larger particles like protons and neutrons. Short points. They are basic building blocks of matter. Combine to form proton and neutron. Exist in 6 types: flavors up, down, charm, strange, top, bottom. Have fractional electric charges, e.g., +2/3, -1/3. Never found alone due to quark confinement. In one line, quarks are fundamental particles that make up protons and neutrons. Do you what are mesons? Let's explore. Mesons are a type of subatomic particle made of one quark and one antiquark bound together by the strong nuclear force. Key points. They are composite particles, not fundamental. Classified as part of the Hadron family. Held together by the strong nuclear force. Usually unstable and decay quickly into other particles. They play an important role in holding atomic nuclei together, especially pions. Example, pion, pi-meson, is the most common meson. Mesons equals quark plus antiquark, particles that help mediate strong interactions in the nucleus. Do you what are baryons? Let's explore. Baryons are a class of subatomic particles made up of 3 quarks. They belong to the family of particles called hadrons, particles made of quarks. Key points. Composition, 3 quarks, e.g., up, down, strange. Type, fermions, they follow Fermi, Dirac statistics. Strong force, held together by the strong nuclear force. Mass, relatively heavy compared to leptons. Examples, proton, P, made of 2 up quarks plus 1 down quark, Yud. Neutron, N, made of 1 up quark plus 2 down quarks, UD. Simple definition. Baryons are heavy subatomic particles made of 3 quarks, such as protons and neutrons. Do you what are leptons? Let's explore. Leptons are a family of elementary, fundamental, subatomic particles that do not experience the strong nuclear force. They are lighter than baryons and include familiar particles like electrons. Key points. Fundamental particles, not made of quarks, unlike baryons or mesons. Types, 6 leptons, divided into 3 pairs of charged leptons and neutrinos. Electron, E, charge -1. Muon, mu, charge -1, heavier than electron. Tau, tau, charge -1, heavier than muon. Electron neutrino, nu, neutral. Muon neutrino, nu_mu, neutral. Tau neutrino, nu_tau, neutral. Interactions, participate in weak nuclear force, electromagnetic force, if charged, and gravity. Spin, all leptons are fermions, spin 1/2. Simple definition. Leptons are fundamental particles, like electrons and neutrinos, that do not feel the strong nuclear force. Do you what are fermions? Let's explore. Fermions are a class of subatomic particles that follow the Pauli exclusion principle, meaning no 2 identical fermions can occupy the same quantum state simultaneously. They make up matter. Key points. Spin. All fermions have half-integer spin, 1/2, 3/2, etc. Examples. Leptons, electron, E, muon, mu, neutrinos, nu. Baryons, proton, p, neutron, n, roll, form the building blocks of matter. Contrast with bosons. Bosons have integer spin 0, 1, 2, and can occupy the same state, mainly acting as force carriers. Simple definition. Fermions are particles with half-integer spin that make up matter and obey the Pauli exclusion principle. What are bosons? Let's explore. Bosons are a type of subatomic particle that follow Bose-Einstein statistics. They are different from fermions in their behavior and spin. Here's a concise breakdown. Spin. Bosons have integer spin 0, 1, 2. Unlike fermions, which have half-integer spin 1/2, 3/2. Behavior. Multiple bosons can occupy the same quantum state simultaneously. This is why phenomena like Bose-Einstein condensation occur. Role in nature. Bosons are usually force carriers in particle physics. For example, photon carries electromagnetic force. Gluon carries strong nuclear force. W and Z bosons carry weak nuclear force. Higgs boson gives mass to particles. So, in simple terms, bosons mediate forces and can pile up in the same state, unlike fermions, which obey the Pauli exclusion principle. What are hadrons? Let's explore. Hadrons. Definition. Hadrons are composite subatomic particles made up of quarks held together by the strong nuclear force. Category. They are not fundamental particles, unlike quarks or leptons. Types of hadrons. Baryons, made of 3 quarks, e.g., proton and neutron. Mesons, made of 1 quark plus 1 antiquark, e.g., pion, kaon. Properties. Interact via the strong nuclear force. Have mass, unlike massless particles like photons. Can be charged or neutral. So, simply put, hadrons equals particles made of quarks. What are gluons? Let's understand. Gluons are fundamental particles that act as the force carriers of the strong nuclear force, the force that holds atomic nuclei together. Key points. Gluons belong to a class of particles called gauge bosons in quantum chromodynamics. They glue together quarks, which are the building blocks of protons and neutrons. Unlike photons, which carry the electromagnetic force, gluons can interact with each other, making the strong force very complex. There are 8 types of gluons, due to different combinations of a property called color charge. They are massless, but still confine quarks tightly inside particles like protons and neutrons. Simple idea. Gluons are like invisible glue particles that keep quarks stuck together inside matter. What is Poon? Let's understand. A pion is a type of subatomic particle that belongs to a group called mesons. Key points. A pion is made of a quark and an antiquark. It is not a fundamental particle, unlike electrons or quarks. Pions come in 3 types. Pi positive pion, pi negative pion, pi neutral pion. Role in physics. Pions act as force carriers for the strong nuclear force between protons and neutrons inside the nucleus. This idea was first proposed by Hideki Yukawa. Simple explanation. Pions are temporary particles that glue protons and neutrons together, helping keep the atomic nucleus stable. What is Kaon? Let's understand. A kaon is a type of subatomic particle belonging to the family of mesons. Key points. A kaon is made of 1 quark and 1 antiquark. It contains a strange quark, which gives it special properties. Kaons are unstable and decay into other particles after a short time. Types of kaons. K, positive kaon. K, negative kaon. K, neutral kaon. Anti-K, antikaon. Simple definition. A kaon is a meson that contains a strange quark, making it important for studying a property called strangeness in particle physics. What is muon? Let's understand. A muon is a type of subatomic particle similar to an electron, but much heavier. A muon is a negatively charged lepton, a fundamental particle, with properties like an electron, but about 200 times more massive. Key properties. Symbol. Mu minus. Charge, -1, same as electron. Mass, 207 times the mass of an electron. Category, lepton, fundamental particle. Lifetime, very short, 2.2 microseconds. Where do muons come from? Muons are produced when cosmic rays hit atoms in Earth's atmosphere, creating particle showers that include muons. Simple explanation. Think of a muon as a heavy electron. It behaves similarly, but is much heavier and unstable. Do you know what is antiproton? Let's understand. An antiproton is the antiparticle of the proton. Key points. A proton, found in the nucleus of atoms, has a positive charge, +1. An antiproton has the same mass as a proton, but a negative charge, -1. It is made of antiquarks, specifically, 2 anti-up quarks and 1 anti-down quark, opposite to the proton's quark composition. Simple definition. An antiproton is a negatively charged particle that is identical in mass to a proton but opposite in charge and internal structure. Important property. When a proton and an antiproton meet, they undergo antimatter annihilation, converting their mass into energy, usually gamma rays. Where are antiprotons found? Naturally produced in cosmic rays, created in particle accelerators like those at CERN. The strong nuclear force, also called the strong interaction, is one of the 4 fundamental forces of nature. Definition. The strong nuclear force is the force that holds protons and neutrons together inside the nucleus of an atom. Important points. Strongest force in nature. It is much stronger than gravitational and electromagnetic forces. Very short range. It acts only over extremely small distances, about 10 to the power -15 meters, i.e., nuclear size. Attractive force. It overcomes the repulsion between positively charged protons in the nucleus. Acts between quarks. At a deeper level, it binds quarks together to form protons and neutrons. Mediated by gluons. The force is carried by particles called gluons. Simple example. Without the strong nuclear force, the nucleus would break apart because protons repel each other due to electrostatic force. In one line, the strong nuclear force is the glue that holds the atomic nucleus together.